Hi Tenfold, my name is Tapang from Videka SSB and I was asking if you could help me with this question.
Hi, Peter Bang. I like your jacket. Please tell me how much was it so I can buy it as well. I think I like it. Guys, let's have a look at what the question says. The question says, in the figure, CD is a bisector of ABC. Now, guys, ACB, I know you guys know English, right? So bisector would mean that it cuts in half, right? So it cuts it into two halves. Please don't say two equal halves, because halves are already equal. So the equal part is not important. With D on AB and AC being less than BC, so the length of AC is less than BC. And then straight line AFE is drawn such that I have that condition there, which is very important. And then let CY be equal to X and let the DY be equal to Y. Remember what I said to you? You always need to go to the diagram and apply what they've told you. So we're told that AD is equal to AF. So it means this angle here, as this side and that side are equal to each other, as you can see on the diagram. And I'm given that D1 is equal to Y, it would then mean that F1 is also equal to 1. If that is the case, it also means that F3 is equal to Y. Why? Because it's vertically opposite angles. So we're talking about that for now. And then that's kind of what we can really talk about there. And then the last thing was C1. So my C1 is down here. I will let this be X. Now, down to the questions. The first question says, prove that the triangle ACF. Let me just try and highlight this. I want triangle ACF is similar to triangle BCD. BDC rather. I can just write it like this. It's still fine. Right? So that's what I want to try and do. So if I can do that, it means that I must try and prove that there's angles that are equal to each other. But I was told in the statement, remember again, that CD is a bisector of angle C. So CD, this line, is a bisector of that. So that makes this angle here to be X as well. So far, I have equal angles in the two triangles. Therefore, I will then say my proof will be as follows. I have C1. So firstly, now I'm being ahead of myself. Firstly, you need to talk about which triangles you are mentioning, right? So you say in triangle ACF and triangle BDC, or rather BCD. This is what I have. I have angle C1 is in ACF, right? So C1 is equal to C2, which is equal to X. This was given, right? It was already given in the statement. And then from there, what I can then talk about is, I will then say angle, what is that? Angle D1 is equal to angle F1, which is equals to Y. This will be angles opposite equal sides, right? Guys, with what I just wrote now, I know you guys love this thing of isosceles nature of triangles. Please, there's no such a reason in life. You don't use what is isosceles nature? Please, don't ever use that. You only say angles opposite equal sides, because equal sides will subtend equal angles. No isosceles nature of anything. I see that in your paper. So, angles opposite equal sides, please. That would then mean that in triangle ACF, I have F4 being equal to 180 degrees. So this is 180 degrees minus angle Y, which is that. Remember, what is this? This is a straight line, right? I'll just say STR, which is straight line. And also I have in the other triangle, which is triangle triangle BCD, I have D2 being equal to 180 degrees minus Y. Also the issue of straight line. Therefore, it would then mean that F4 is equals to angle D2, and then they both equal to 108. Then lastly, I will then say angle B, or not B. Remember, we're starting with the other triangle, right? Not BCD. And in triangle ACF, the remaining angle will be angle A2. So it will mean that A2 is equal to B. Remember, the reason for this will be remaining angles of a triangle. You can say remaining angles or third angle of a triangle. It doesn't really make a difference if you say the two. Therefore, I will then say triangle ACF is similar to triangle BCD. And then the reason for this will be angle, or rather angles in proportion. Mathematics, food for the soul. Lastly, or not really lastly, the other question, they are saying to us, prove that AC over BC is equal to AD over BD. Remember, AD is the same as AF, right? So that's important to please note there, because we might use that. So from the previous question, I told you, or we saw that ACF was similar to triangle BCD, right? Now I'll try and get the ratio from these two things. So what do I want? I want to have AC. So here's my AC. I also want to have my BC, or rather my BD. So from there, I will then have also AF. AC will go with BC rather. And then I'll have my AF there, which will go with my BD, because there's BD, there's BC, which I have. I have BC as a yellow there, BD as a green, and then I have AC as a yellow, and then AF. AF and AD are equal. Remember, that's what the statement said. So it would then be AC over AF is equal to BC over BD. But AF is equal to AD. You'll just say this is given, please. So this is given on the statement. Therefore, it means I have AC over AD is equal to BC over BD. So I want to get it in that form that they have there. So I can just cross multiply, though I'm not removing the fraction. So if this can move there, because it's the same thing. So this will be AC all over my BC is equals to AD divided by BD. So that's what I have there. Then I've proven what they wanted me to prove. Then let's look at the next question. The next question will then say, prove that, or rather, is AC a tangent to the circle through points A, B, and E? Give a reason for your answer. Now, as soon as I see this, I'm thinking to myself, no, it's not a tangent. Why? Because there's no circle. But I'm kidding. That's not what you try to do. If you're trying to talk about something being a tangent or not, you need to prove. Remember, I've been mentioning it. You prove 10-chord theorem exists. Not you prove 10-chord. You prove whether it exists or not. Then you can claim being a tangent and then talk about converse of 10-chord. So that's what we are trying to do. So looking at this question, this is what I have. I have, if I want to prove that AC, which is this length here. So if I have AC there, I want to prove that AC is a tangent to the circle through these 3 points there. I will roughly draw it like that. It means I'm trying to prove that, so my required to prove is that A2 is equal to angle B. Now, so that's what I want to do. Then my proof will then be, remember what did we say from the other questions? We said that triangle ACF was similar to triangle, where is it? BCD. Was similar to triangle BCD, right? So if those conditions are happening, it means that the angle at A is equal to the angle at B. You remember the equiangular thing. You see that? Yes. So I will then say in ACF, the angle at A is A2. Then you say A2 is equal to angle B, the whole of B, because there's no things there. Then your reason will be equiangular. Oh my God. Guys, look at this. Huh? Do you hear what I'm saying? Do you hear this English I'm using here, guys? A2 is equal to B. Therefore, AC is a tangent. Then the reason for this will be converse 10 chord.